Hey guys, this is Joe with the Adapt team. In this video, I'm talking about adapt sources. To best explain adapt sources, I'm going to go back to a diagram I showed in a previous video that essentially depicts how a user controls a user interface, and then user interface ends up controlling devices downstream. The first thing to remember is that a user, when their finger is on a touch panel or they're pushing a hard key on their remote, those are just digital signals in simple windows on either their TSW panel hardware or their HR310 hardware. And then we already know that that hardware interfaces with our adapt module, right? So our hardware hooks up to our adapt module, and then this adapt module, for our user interfaces, communicates back to our adapt core. And then, for the gentleman on the left, if he's looking at the autonomic source, he's currently controlling autonomic, then all of his button presses and join numbers are going to go to our adapt autonomic module. And because our adapt autonomic module is connected to the actual autonomic hardware, that's how our source ends up getting controlled. On another note, if that same gentleman then switches sources, well, now all of his joins and his button presses are going to go through onto that source, and maybe that other source is controlled in some other way. Works very similarly for a handheld remote, except now instead of join numbers, these are just regular old digital joins getting thrown high. And again, depending on whatever source is active in that handheld's room, those hard keys are going to get forwarded onto its appropriate source, and now you're controlling that source. Real quick before we get too far into this, what I wanted to show is in simple windows, this chunk of joins that I've talked about that gets reused for every source in our system are these joins right here. They're joins 121 through about 420 or so. So you've got 300 digital joins with feedback, of course, going to every single device, including sources in our system. And we also have analogs. If we go over here, it's analogs 21 and up, and then same thing with serials. It's serials 21 and up. And so these are the joins that get reused for every device in our system, and so that's going to become important when we start bringing in our source modules. So we do have quite a handful of adapt source modules. Sources are where we oftentimes see the most deviation from one job to the next, and honestly it's even by the region, your geographical location, you may be using different module sets than somebody else, but the idea is that any one of these generic adapt modules should be able to control any source that you can throw at it. And when we first started adapt, these were in fact the only modules that we had were these generic modules, and everything was kind of approached in a very generic way. We have a generic full, IR basic, IR channel presets, and no controls. I'm actually going to talk about those to start us off here. So with a generic module, let's go ahead and bring in a generic full. The first thing that I want to think about is how is my handheld remote user going to get to control this source? What happens when I push the menu key? Well, what happens is, again, the user interface is going to interact with our adapt core. The core is going to communicate with this source module, and in the case of handheld remote control hard keys, these corresponding functions under the quick control section will fire upon your user pushing one of these buttons, right? If your user pushes the info button on your handheld remote and that remote is controlling this particular source, then this digital right here will fire. And the idea is that you would hook up your source's IR driver to these quick controls right here in whatever method you want, right? We want it to be flexible so that you get to define the IR function that gets fired when your user pushes the menu hard key on their handheld remote. So oftentimes when you're doing a generic source, this is our first step, is to define our quick controls here. And again, quick controls are our handheld remote control hard keys. Then we want to talk about these standard digitals here. This is where that chunk of joins comes into play. If we take a look even at this first signal, you'll see it's called play and then underscore 121. Well, the 121 is actually the join number that this signal right here is going to correspond to. So when my user goes to a touch panel and they fire join 121 and they're controlling this source, this is the digital that will go high right here. And then again, the idea is that we're hooking our IR driver up to this signal here. Now, the reason that we've put the actual function names beside this is because, of course, we've already generated a good handful of these pages for you in VT Pro, and we've reused these joins, right? So if we look at this first page here, this is my DirecTV page. We are using join 121 for our play function here. Well, then if we also look at our Blu-ray, our Sony Blu-ray page, which of course also has a play function, it is also at join number 121. And so the idea is that we've attached function names in our VT Pro projects to these join numbers, and we've kind of reused these join numbers all over the place. And so it makes sense if you just kind of reuse the functions and the join numbers that we have kind of attached to those here. And those will be our standard digitals here. Touch panel controls is what this section is all about. Of course, we can feed feedback back into this module if we'd like. Now, what really differentiates a full module from the rest of our modules are these standard analogs and serials. If you do have a source that is providing you, some sort of analog feedback, we've given you a place to put that in. Or if you need to sort, or I should say send an analog to your source, you're welcome to do that off the right side of our module. And in serials, we give you the ability to feed serials into your source up to, about 100 serials that you see there. There's two last signal groups I want to talk quickly about. One is the list controls. If you have a source that has list-based controls, using our list can make a lot of sense. You can define what button presses on your list do. You can feed feedback to kind of light up buttons in your list right here, and you can also feed text into your list to show any sort of serial feedback. Right? In fact, we've utilized these list controls on our Sony Blu-ray page. This is actually our list right here. You can see that it's Smart Object ID 5. This list actually does exist for every device in our system. Every device has this exact controls list at Smart Object 5 that we use for it. We just happen to have fed in some serials and attached some functionality to this list. The last signal group I'll talk about real quick is our automatic controls. The way automatic controls work is these first two digitals will fire in sequence when the source goes in use by anyone in the system. Okay? And then the bottom two signals will fire in sequence when the source goes out of use. This is what you're going to use for sources that maybe require some power on sequence or need to be woken up, or when they get told to turn off, maybe you might want to pause that source, or if it's some source you want to actually turn off, you can maybe pause it, and then if it's still out of use for 60, 90, or 120 seconds after that time, you can then power off that source. And that's what automatic controls are all about. Now, this is our generic full module, so this is by far the most intense and the most capable module of all of our generic modules, and the rest are kind of subsets or dumbed down versions of this full module. So let's take a look at the next generic module, which is IR Basic. Our IR Basic module looks very similar. For our standard controls, we no longer provide feedback since this is for a IR, basic controlled device. So obviously we do not have feedback. So instead of digital feedback, we just provided you some basic serials right here to feed in if you need to feed in serials for whatever reason. The list controls, quick controls, and automatic controls work identically as the full module did. The only difference between that IR Basic and the IR Channel Presets is that instead of a list controls, kind of a generic approach to this list, we have now reserved this list for channel presets. So the channel presets are available and exposed to us here instead of the list controls. But of course, the channel presets is essentially this ability to allow the user to store and then later recall channel presets, and those same presets are exposed to you here in Simple Windows for any sort of custom functionality you may be trying to provide. There's a couple more generic sources. One is our generic multi-window processor. This is what you're using for any video wall type applications. We give you hooks to select from up to 32 window layouts, show and hide various windows depending on that layout, and then feed sources in to your multi-window source, as well as get feedback for the sources in each individual window. This is documented fully in our documentation, which again you can reference by hitting F1 on any one of our adapt modules. The last kind of generic source module I want to talk about is our no control source. This no control source is for any sort of game console or PC input or any other source that is just simply not being controlled, maybe digital signage or something like that. Essentially, it has a NIT and a source number, and then some opportunity for informational text to maybe instruct your user further. You know, use the Xbox controller for this device, or there are no controls for this device, or some examples of what you may want to put in here. And so those are all of our generic modules. In just a sec, when I talk about these source-specific modules, just know that all of the modules that you see, including these source-specific modules, all derive from these generic modules. Like I said, for the longest time, all we had were these generic modules, and then we started to deploy some of these source-specific modules. Okay, so let's get into programming the rest of this training residence and the sources in our training residence. Just to remind everybody, including myself, these are the sources that we are looking for in our training residence. So let me start with these video sources. So let's do DirecTV, TiVo, Apple TV, Roku, Kaleidoscape. Okay. For DirecTV, I noticed that I have a DirecTV module right here, so let me go ahead and just pull that in. I'm going to give this a NIT, and this will be source number 1. The first thing that you will notice about this DirecTV specific module is that this module is much more trimmed down compared to our generic modules. And in fact, this really only has one necessary signal, and it's this packet transmission signal. Packet transmission symbol here functions very, very similarly to how it did with dynamic IR, except the only difference here is it's not really dynamic. All of the IR commands are kind of built into this source module here, and so depending on the port number that you have specified, the module understands what all signals need to get fired at what time when you push, you know, specific buttons. And of course, this does hook up just like dynamic IR, however, where we hook this packet transmission signal to the packet transmission symbol or slot on our hardware over here, wherever that device may be controlled from. And if, like I've kind of done throughout, I am going to go ahead and give this guy a comment now to remind myself that I am done. TiVo is my next source. Let's go ahead and pull in a TiVo. This is works very, very similar. This one is going to be source 2 packet transmission. And so I'm going to give it source 2. I'm going to make sure to define my port number here as well. And this right here should demonstrate that you can in fact add multiple packet transmission signals to this packet transmission extender here. And again, now I am done with this source. So hopefully you should see these sources are quite a bit easier to hook up than these generic sources. These modules are one-liners compared to some of the additional work may be needed on that generic module. Alright, so we have DirecTV and TiVo. Now let's do Apple TV and Roku. These function exactly the same way. I'm going to do init. This is going to be source number 3. I'm going to control on port number 3. This will be source 3 packet TX, and I'm going to add that down here. I've also got, let's get that comment. I've also got my Roku module here ready to go. And this will be init. This will be source number 4 packet transmission. This will be IR port 4. Now it does not matter the order in which these packet transmission signals are attached to my extender here. All that really matters is the port number that I've defined here on my module and the module itself. What module are you using? That's what's going to govern the IR commands that get sent. Now we do have a Kaleidoscape in here as well. Kaleidoscape is one of our source specific modules, but of course typically we want to control our Kaleidoscape over IP, and it works very similar to some of the other modules that we've seen. Since we are controlling over IP, we are going to want to have a TCP IP client in our system. I'm going to give this an IP ID here. Of course, you would also want to fill in the IP address of this Kscape. But if you notice, this Kscape module is auto-importable. So what we can do is we can just right-click and drag onto our TCP client, import device logic. This will be source number 5. And my module has auto imported. The only thing that is not possible to import is this port number, and we've put that down here for reference. Your port number is 10,000. And now this source module is set up to control our Kscape over TCP IP, and of course you would typically want to put in your IP address here in Simple Windows. Okay, so that's our Kaleidoscape. The next source I'm going to do is a MMS2A, an autonomic. The first thing I'm going to do with this source is I'm going to go ahead and add its IP ID. Let's add it right here. I'm going to do autonomic 2A right here. And we also have a source module for this. It's right here, autonomic MMS. And what I like to do in my systems, and this is totally up to you, but what I like to do is I like to separate my video sources from my audio sources. And what I mean by that is, so far I've used source numbers 1 through 5 to represent my video sources. So what I like to do is I might want to jump down to, say, source number 11 for my music sources, and because this is a 2-stream autonomic, maybe this is going to be source number 11 and 12. All right. Again, this module is auto importable, so all I need to do is right click drag onto my autonomic. You can see the prefix I use here. I am going to incorporate both of these source numbers just so I have them there, and if you see, my module has now populated itself. I will go ahead and give this a comment. Now, typically control for autonomic is done through Crestron's Media Player Smart Object, and in fact we have a VT Pro page specifically dedicated to that. You can see our Media Player Smart Object is right here, Smart Object 15. Now, just as a reminder, hopefully you are familiar with Media Player and how it works, but if you're not, the way too brief rundown of how Media Player works is, here's our Media Player object right here. This object interfaces with this Media Server Object Router module that is typically included with each touch panel. We are using the 4.0 version. And the way that this module works is based on the analog value that comes in here. Let's say it's a value of 3. The program will take the CRPC traffic to and from device 3 here in your program and forward that communication on to that touch panel's Media Player Smart Object, and that's how the Smart Object actually communicates with the device, is through this symbol right here, this Media Server Object Router symbol. Now, the way that we used to program this is you used to have to go to each touch panel, and when you say had device 3, you would attach, source 3 CRPC right here, and actually this would be the CRPC feedback, and you would feed the CRPC over here, and you would have to do this for each touch panel in your system, right? Because each touch panel has its own Media Server Object Router. And so that got kind of annoying for the same reasons that I've talked about throughout training, is when you add a source or you add a touch panel, now you've got to do this special kind of stuff, and we want to try to avoid that. And so what we've done is, instead of hooking those CRPC signals directly to each touch panel's Media Server Object Router, instead we attach it to an analog buffer, and this analog buffer kind of acts as a signal splitter. It kind of takes this one serial signal input and distributes that to every touch panel in our system. And this buffer works in both directions, so we can take CRPC feedback from our devices, have those get fed out to our touch panels. We also use this for the direct connect, and we use this with our CRPC2 devices. So now the CRPC from our touch panel goes to this buffer, which I can then transmit to my source device. So all of this is to say is that we still need to hook up our media server CRPC signals. We've landed those signals right here on the module, so that all I have to do is take CRPC right here and land that on my buffer. That's going to be my CRPC from device, I want to say. Excuse me, this is going to our device, so this is going to go into this analog buffer on the to device here. And then the from device is going to go up here, so let me grab those signals. And it is important to line these up with the source numbers that I am using, right? So I'm using source number 11 and 12 here, so it's important that I put these on the lines that line up with from device 11 and 12. And then I, of course, know when this autonomic is offline through this extender right here, and I will use just a regular buffer, regular digital buffer, to tell our media server, or media player, excuse me, when our devices are offline. Did I connect the direct connect? No, so I need to connect the direct connect as well, and that is right here. All right, and so for any media player source that you have in your system is going to follow this exact model, where I'm going to first pull in a adapt source module to represent that device in the system, and then I'm going to connect up the CRPC signals and land them on this analog buffer. You see this CRPC comes straight from our autonomic hardware, and so we're using these two buffers to help make our media player programming a little more efficient. And so those are all the sources that are being distributed. Now, if I look back in my PowerPoint, we do also have that local theater zone. So I want to make sure that I'm representing that correctly. And just as a reminder, this local theater zone, or excuse me, the theater zone has a local Sony Blu-ray and a local Xbox. And so I want to make sure that those are represented in my system. Of course, we have a Sony Blu-ray module right here. I'm going to pull that in. I'm going to give this a init, and maybe I want to separate this one out too. Maybe this one will be source number 21. So I'll use source 021 packet TX here. And because this is a local source, maybe this is controlled from the RMC that's in that theater zone, which is on output 1. And so I'm going to go ahead and add my source 21 packet transmission right there. Now I very well could have used this signal. I just prefer to keep sources separate from my display, so that's why I've also just added this packet TX here. And then I have that local game source, so it's a perfect opportunity for me to use my no control source. And so this one will be source number 22, and I'm going to say use your Xbox controller for this device, and this last line will be blank like that. I'm going to go ahead and make sure I'm commenting. Now the rest of these modules are auto importable, so if you're using any one of these kind of first 5 or 6 devices or so, these modules will auto import onto their respective hardware. You'll still need to connect their CRPC signals to our buffers that are down here, but after you do that, you will be set up for your sources. At this point, we are finally ready to compile our program. Whenever you are compiling programs, we always recommend that you recompile all. The shortcut for this is Alt F12. When we do a recompile all, this sometimes helps us avoid any sort of compile issues that may arise to our program. And so we always recommend doing a recompile all, and we will wait for that to kind of happen here. Before we load our program, we will of course want to make sure that we have what we call a clean compile, meaning that there are no warnings or errors or notices in our compile, just so that we know that we are starting off on a good foot with our compile. So we will let this program compile, and we will come back and see how we did in the next video, where we will go ahead and load this program and start on some of our adapt config, and we will see you in the next video. Thanks.